Hello, my name is Ojas Chaudhary and I've worked on Design Assignment 2 and I've worked with group members whose names are on the slide. Here is an image of our group. The problem is to design a tri-vectorian oven developed by GE that can cook a pizza loaf using all three methods of heat transfer: conduction, convection, and radiation, and achieve the maximum tastiness as described by a formula. The device needs to vary the power consumption of the skillet and the microwave to reach maximum tastiness score in 60 seconds. The predefined conditions for the convection heat transfer coefficient and air temperature are on the document. The pizza loaf is a half-cylinder shape with specific material properties and initially at 4 degrees Celsius. The oven needs to heat the loaf for 60 seconds with the given parameters for the skillet, convection oven, and microwave. The final tastiness score is calculated based on the formula that takes into account the temperature, density, and mass of the loaf. I primarily focused on writing the FlexPDE code and helping modify the code too. I also helped in writing the report and making the flowchart in the report. The goal of the simulation is to find the optimal power setting for a microwave and skillet to cook a pizza loaf and achieve the highest possible tastiness score. The transfer in the loaf is modeled using the equation and is simplified to a 2D problem due to the symmetry of the loaf. Variables are given in centimeter and grams per centimeter cube, so SI units are not used in the simulation. The pizza loaf can be described by the heat equation, which involves calculations of volumetric heat generation and heat flow using integrals. The low conditions are set to ensure that the skillet is insulating and the crust absorbs heat through convection and radiation. The final calculation of tastiness involves integrating the difference between the temperature and the ideal temperature over the crust and filling the dividing by the mass of the food. The simulation of a pizza is in a skillet. It requires load conditions to be set for each region and describe the heat flow. The skillet edges have a temperature of 0 and are insulating to prevent heat absorption from the convection. The pizza crust has a load condition of -H times T infinity minus temperature on the top and side surfaces to absorb heat from convection, while the bottom and 0 load to present no convection. The pizza filling has internal volumetric heat generation from microwave radiation and no convection, thus it has load condition of 0 on all surfaces. The FlexPD script was written using the base code from the first design assignment, with most values modified. The code produces a result and shows the exponential increase in the tastiness score as the temperature of the loaf gets closer to the ideal temperature. Heat can be seen flowing in from outside and up from the skillet, affecting the temperature plot. The inside of the loaf has a lower temperature from the outside due to the limited nodes of heat transfer. The tastiness score is reported as 2.44 times 10 to the power minus 4, which is not the 0.05. This discrepancy can be disregarded as due to the different cooking time for a similarly sized loaf. The overall logic in the validation of the model appears to be accurate though. Now to see the optimization, we modified the existing code slightly as seen in the image here, with the printout export format line to export the graph and save it as text. And then we also changed the input of the P skillet and the P microwave. This code is the auto sweep. This has all of the necessary functions to be able to sweep through the flex data, file data, organize the results, and run the files. A FlexPD model has been validated and Python code created to sweep power values for the microwave and skillet. The code was divided into multiple modules for future use. The program will generate a range of power values from 3.3 kilowatts to 0.1 kilowatts for both appliances, with 10 data points per range, resulting in 100 data points. The data will be plotted as a 3D scatter and optimized until the wattage range for both appliances only spans 100 watts each. To prevent hardware issues, the program will break the 100-point data into chunks if more than 50 are present in the sweep range. So in doing this, our first iteration gave these values and this graph. Second iteration gave these values in this graph. Third one gave these values in this graph. And the final iteration gave this graph and these values. In summary, the optimal power for our skillet and microwave were found to be 512.62 watts and 2183.10 watts respectively, yielding the maximum tastiness of 0.02544. The results are obtained using FlexPD and Python. However, the project had limitations such as ignoring moisture and assuming no heat loss from the oven, and was only a 2D simulation, which led to some inaccuracies. The result can be considered reasonable, but the floating point error of ±4 watts. Thank you.